Hello, it's dumplet here. Here's an item on geometry. A right square pyramid with volume 54 has a base with side length of 6. The 5 vertices of the pyramid all lie on a sphere with radius m over n. And we're asked to get m plus n. So m and n are relatively prime positive integers, so m over n is in lowest terms. Credits to the American Invitational Math Examination for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, this question, it is 3D geometry, and although it's hard to visualize, we could make our own creative ways to kind of understand the solution. And here, I'm going to propose that we're going to do, well, obviously we have to draw the figure first, and I'm going to label points on the pyramid, as you can see here. So we could label and we could refer to those points and segments, whatever, a little bit more easier. So let's talk about what we have. We have the volume to be 54, and then the side of the base, I guess, to be 6. Now here I made the square base to be BCDE, and the right square pyramid just tells us that it is symmetrical if you take a look from the top and the bottom. So we can say that AB, AC, AD, and AE, they are of the same length. So you can kind of say that from the top view, if we do have a top view of this pyramid, A would be exactly in the center. So that's a way to visualize it, all right? Now, with the given we have here, well, we do know the formula for the volume of a pyramid. It's going to be 1/3 times the area of the base times the height. Now, our base over here, it's going to be the square base, and we do have a side length of 6. So we know that the base, the base has an area of 36. So we know that 54, it's going to be 1/3 times the base times the height. Now the height in this case, now I just mentioned, since from the top view, it's going to be, A would be directly at the center. So obviously the height, it's going to connect A to, let's just call this F, which is going to be the center of the square, all right? So obviously, because of symmetry and all, and because of the given here, we're going to have this condition. So AF, which is essentially the height, we could solve for the height. So we get 54 is equal to 12H. So H here would be 54 over 12, so 9/2 in lowest term. So this portion will be 9/2. Okay, I don't know how to use it yet, but let's try to go back to the question. That's not really the question. We have a sphere where the 5 vertices are on. So we might want to figure out where is the center of the sphere, and just to kind of visualize or kind of grasp this figure a little bit better. So I did mention this because of the conditions in the given. A, if I were to take a view from the top view, A would be directly in the middle. So essentially, you could kind of think of it as like the intersection of the two diagonals of the square. But from the top view, it will seem that A is in the middle of the square. Now, because all 5 points are on the sphere, the top view suggests that, okay, the line that goes through the screen through A, which is in effect the height, because I know AF, the segment that involves a height, because A and F is the center of the square, so AF is going to represent this line that goes through the screen here. So the center of the sphere should be somewhere on this line. And that motivates me to consider a triangle. It allows me to consider a triangle ABD. Now, why triangle ABD? Because I know BD is a diagonal, and BD will contain this point of F, and I could know that triangle ABD has AF, which does contain the center of the sphere. So considering ABD, and I know the center of the sphere, I don't know where it is, but let's just say it's here for now. Let's just call the center O. this just boils down to solving the circumradius of triangle ABD. Because we know where the center is an AF. So the center of the sphere is an AF, and I know point A, point B, and point D, they are all points on the sphere. Although it is a sphere, obviously, we could reduce it to kind of solving for the circumradius of the triangle ABD over here. And that's pretty interesting because we have practically everything we need already. So let's recall the circumradius formula. So the circumradius is going to be product of the sides ABC divided by 4 times the area. Okay, so let's go back to the figure. BD, okay, BD is, with respect to this figure, BD is our diagonal. So first, I know BC equals 6, CD equals 6, and since we have a square base, angle BCD would be right. Okay, so we know that BD, it's just going to be the hypotenuse of right triangle BCD. So I know that BD squared, it's going to be equal to 6 squared plus 6 squared. So BD squared would be 36 plus 36. That's going to be 72. So BD will be equal to the 6 square root of 2. So BD over here is 6 square root 2. Next, I know what AF is. AF is 9 halves based from the formula a while ago for the volume of the sphere. So height is 9 halves. So that's AF. And I can say that we have a right triangle AFD. Right triangle AFD. We could use Pythagorean here because AB and AD are the same based from the right square pyramid condition. So we do have AB equals AD. So isosceles triangle ABD with an altitude of AF, technically, it's going to split BD into 2 equal parts. So FD, so this is point F, FD would be 3 square root 2. The height is 9 halves. So 9 halves and then the 3 square root 2, that's going to allow us to get AD. So AD squared, that's going to be equal to 18. So 3 square root of 2 squared, that's 18. Plus 9 halves squared, that's going to be 81 over 4. Combining this in one fraction, we're going to have 72 plus 81, so 153 over 4. That's going to be AD squared. Now, I could take the square root, but I realized AD squared, it's also the same as AB times AD. And that's going to be 2 sides of the triangle, AB and AD. So I know that the product of the 3 sides would be AB times AD times BD, which is this 6 square root 2. So let me go back into this formula. I know that this part is going to be the 153 over 4. That's going to be AB times AD. And then the 6 square root 2, which is the third side. I would divide this result by 4 times the area. So let's just go back and get the area. Let me rewrite the figure so that we could get the area a little bit better. But everything is already here because we already have AF, which is the height. That's going to be 9 halves. And we already do have the base as well. It's going to be BD in this case from this figure, although it's a little bit ugly. But BD, it's going to be 6 square root of 2, as mentioned. So the area, it's going to be 6 square root of 2. Oops, 6 square root of 2 times my height of 9 halves divided by 2. So let me just put the 1/2 here on the outside. So we could just simplify this. I see a 6 square root of 2 I could directly cancel. The 2 2's cancel with the 4 nicely. So I'll have 153 over 4 in the numerator and then 9 in the denominator. Simplifying this, I'll get that the radius, it's going to be the 153 and the 9 cancels, so 17. So the radius of the the circumradius of triangle ABD would be 17 over 4. Going back, because the center of the circle is on is on AF, and A, B, and D are points on the sphere, this 17 over 4 will also be the circumradius of the pyramid. Yeah, it's going to be the circumradius of the pyramid. So it's going to be the sphere, it's going to be the sphere's radius. But we're not yet done because this is AIME format. This was our m over n. So our m plus n would be 17 plus 4 And that's going to give us the final answer of 21. All right, so this is the final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.